So we got other special integration problems. Number one is the absolute values or piecewise, and then we have back U substitutions. So let's go over these ones together really quick. Absolute value, then back U substitutions. So here we go. Here's our first problem. It has an absolute value here. So we're gonna split it up, which is the piecewise function, find the breaking point, integrate, and then in this case, there's a fundamental theorem of calculus because it goes from 0 to 1. Now, if we were to graph this function, I just want to make sure we're clear. It would go over to the right and it would look like this, right? There would be like a little V. And so that means there's two equations here that we have to focus on. So we're going to split this up and we're going to do two equations. So this is called a piecewise equation here. One is going to be just the x, oops, it's not a plus, it's an x minus 1. And then the other one has to be the negative of it, x minus 1. So now we have this piecewise function that we have to integrate. But let's find out what the breaking point is. And if I let this equal 0, then x equals 1. So that's the breaking point right here. I'm going to put a little breaking point there. Now that means that this thing here is going to be from x is greater than 1 and x is less than or equal to 1. And so that's the breaking point here. So since this goes from 0 to 2, now we have from 0 to 1 plus from 1 to 2, right? Two integrals now. We have to break it up into two functions here. So we're going to put this 0 to 1 since, nope, that's going to be the 0 to 1 is the bottom one. And then the 0, yeah, I think so. Let's make sure. Yeah, that's working. Okay, so this one is going to go the first one, and then this is going to go the second one because it's greater than 1, so it's going to be from 1 to 2. So I have the integral from 0 to 1 of the negative part. And then we have to add in this 1 to 2 of the positive one. And then it's a simple add a power, divide by a new power after that with the fundamental theorem of calculus. So let's see if I can do this all on this little tiny piece of paper here. Let's make my pen a little smaller. I'm going to have a negative x squared over 2 minus x from 0 to 1. And then I'm going to have my plus x squared over 2 minus x from 1 to 2. All right, let's see if we can plug this stuff in and be done with it. Put the 1 in, that's negative 1/2 minus 1. And then let's put the 0 goes away, so I'm not going to worry about that. Let's put 2 in there, so 4 over 2 minus 2. And then we're going to subtract now the other part, 1/2, and then a minus 1. All right, and that's good enough for me. I like that idea. So let's move on to the next one here. Our back U substitution. So back U substitution, we're going to do a normal U sub, find the du, but then we're going to need this back U substitution, and then we integrate. Because something's fishy with this x on the outside. So I'm going to go back to this and say a basic let u equal x plus 2, right? Because that's the part inside in the square root. That's where the chain rule applies. But when I find the du, that's just dx, which is just my dx, but I have this extra x in there. So now what do? If I did this, it would look like x root u du, but I have that extra x in there. So that's a problem. You can't just delete it or erase it or something like that. We're going to have to back U substitution it. Look at how this is the x and this is the u. Well, let's subtract 2 on both sides and get x equals u minus 2 and plug that into the x that was left over. So now our new integral is u minus 2 and then root u. Interesting. So I can't really do that yet until I distribute this. And so we're going to distribute it, and that becomes u to the 3/2 minus 2, u to the 1/2. And now let's integrate it by adding a power, divide by a new power. U to the 5/2 over 5/2 minus 2u to the 3/2 over 3/2. And now I'm going to put a little plus constant on there. I'm not done completely because I got to put the x's back in. So x plus 2 in this. So let's put it over here. So x plus 2 to the 5/2 over 5/2 minus, that's this one, minus this one now, 2x minus 2 to the 3/2 over 3/2 plus a constant. So that's our back U substitution right there, and I wish you some good luck.